Hello everybody and welcome to my poster pitch on analyzing surface and atmospheric UHI of topographically and morphologically different cities in India. My name is Sutapa Bhattacharjee and I am a PhD student from the Department of Civil Engineering in the Institute of Technology, Guwahati. This study is part of a bigger project intended to understand the microclimatic conditions of monsoon-dominated cities in India. Well, in the present study, we aimed to understand the surface as well as atmospheric heat island scenarios of two cities, Kolkata and Guwahati, lying on similar climatic regime, but they differ significantly with respect to the surrounding topography and existing city dimensions and geometry. Kolkata is one of the major metropolises of Asia with very complex and intensive urban architecture surrounded by plains and about 200 kilometers from the Bay of Bengal coast. However, Guwahati is a much less denser class 1 city lying on the bank of the mighty river Brahmaputra and having undulating topography. We tried to simulate 1 kilometer resolution skin as well as 2-meter air temperature conditions for both the cities by dynamically downscaling existing GCMs, coupling warp model with high-resolution urban parameters derived using Sentinel-2 optical data products, applying SVM machine learning algorithm. Two-way 3-tier nested domains were configured, where the outermost parent domain contains the northern Bay of Bengal and parts of eastern and lesser Himalayas to include the influence on the regional atmosphere and define the boundary conditions. The model was calibrated integrating meteorological, topographical, and land surface data products for the entire region, along with suitable atmospheric and urban physics options, and simulations were run for the month of July, which is the hottest and most affected monsoon month at 3-hour time step. The simulated results and model validations indicate that the surface and atmospheric urban heat island conditions of both cities have considerable differences. Kolkata experiences rise in surface temperature from late morning, which peaks in the afternoon, since the city core, which contains most compact urban structure and higher roughness quotient, takes longer duration to heat, also slowing the process of increasing air temperature. Moreover, the core city retains the accumulated heat for longer duration, generating higher nighttime atmospheric UHI effect due to the long-wave radiations released from the urban morphology, irrespective of the coastal influence on the city. However, both surface and atmospheric UHI follow similar trend over Guwahati due to relatively lower complexity in urban surface structure, and their concentration is higher in the nighttime in the city core. Therefore, it was evident from the analysis that urban surface morphology has a greater influence on the local climatic variations of the cities compared to the surrounding topography, which would assist the city planners to develop a systematic approach to deal with artificial heating phenomenon of the cities more comprehensively and sustainably. Thank you. Have a great time at JURS 2022.